Let us warmly welcome Mr. Saptarshi Debnath.
Thank you. Hey, this is Saptarshi. Hopefully, you are able to hear me and this see my screen.
Yes, sir.
Okay, thank you. So today's topic that I want to discuss is architecting scale. So as you heard, right, I'm a software engineer. I have over 17 years of experience working in this industry. I primarily have worked on travel and health sectors. I have also worked on some niche technologies, right? Like developing games for OpenGL using OpenGL. But my primary work have been to maintain backend services or web services for well-known travel companies, travel company. So I wanna, like, as you understand, right, I have worked on scenario where where you're working here for startups and we just want to ship a product or application to keep the light on, right? Or rather innovating for tomorrow, right? So like both the kind of systems, right, and both the kind of scenarios produces applications which are totally different, right? And both we are going to investigate like which is better, which is bad, and what works and what doesn't work, right? Specifically for scaling part, once your product is hit, right, everybody tries to use that. How will you use that, or how as a developer or as a designer or an architect, right, you're gonna implement that, or what are the decisions you can take, right? So we have two worlds, right? In first world is a startup culture, where you are trying to take a break, it's chaotic, right? And like everybody is trying their ideas and everything, right? So how do you, what kind of application you write? Most of the time it will generate something called a monolithic application, right? So a single binary, single application which will try to do everything because you don't have time to do proper design or implement all the things correctly, right? You just want to ship the product, and hopefully you are writing something that actually is liked by everybody, right? Your goal is to actually ship the feature rather than actually making it design product, making it scale properly, right? But if you move to a larger enterprise, right, the goal shifts drastically, right? Here the goal is that everything should be organized. You should move calmly. You need to, before you put anything in production, you have to make sure that nothing blows up, so that there is no loss or revenue. A lot of different terms come into the play, right? So these are two different cultures that we generally see in the software industry. For one, in the startup, downtime is bad, but not as bad in the large enterprises, right? For example, in hospitality, downtime means lost revenue, right? In during the Christmas, if you have reservation systems going down, then you have a big problem. Nobody's able to fly or book hotels, book taxis, everything, right? That's a big problem. In healthcare, right, if you are if your system is down, then doctors are not able to check reports, right? Everything is digital now, so everything routes through a web server or a software to handle that, right? But if you are running small application, it's okay that you are down for 30 minutes, right? You might get a bad press, but it is not going to be $1 million impact. Okay, so we are going to investigate both the ways and see how it works out. Okay, so first implementation that we're going to check is the monolith or big ball of mud, right? So when you are writing application very fast, right, you don't have time to actually design it properly, right? You are shipping features fast, right? But it does have have its advantage that you are shipping product very fast, right? People are liking it, and when the number of users of their application is relatively low, right? So it should be fine. It should be more than fine, right? And if you just need to uh, like if there's an uptick, you can throw in more infrastructure to it, like buy more CPUs or memories or GPU, right? Whatever you need, and just run it, right? But ultimately, right, when you are going to be a big company, you are seeing that you are becoming a big company. This pattern of writing a single application, a single ball of mud, right, to write your application might not work out great, right? Because at that point of time, your demand will be time specific. For example, in the morning at 9 a.m. in the morning, right, your traffic might be huge, right? But it might taper down, right, when it's at a 12 in the during the lunchtime, right? Then at that point of time, your servers will be remaining unused. But in the evening time, right, you have your demand might grow again, so that your servers are you have to add more resources or infrastructure to your web data centers to serve all the traffic. So there is a um, curve to it. It's not a static load or amount of requests you'll get. So you have to adapt to it, right? Because nowadays anybody can go viral at any point of time, and and the and the ask is that you should be able to drive that traffic, or handle that traffic, or handle that amount of traffic with ease. That's how what is the expectation. So when you write big ball of code, or that becomes an anti-pattern with this current scaling, or in the cloud scaling, right? Tight coupling, scalability, reliability, fragile deployments, and fear-driven development, right? So when your scaling is affected, right, you are throwing in money just to stay afloat, right? Which doesn't make sense. Reliability becomes a problem because there will be ghost codes, or codes that which have been written long time back, and you don't know how they are behaving, right? And if you're out running out of infrastructure, right, then you will be going down. So reliability is a problem. Deployments takes a lot of time to go through, because once you deploy, you have to check all the aspects of the monolithic application, right? And this introduces a fear driven development, right? Whatever is working, don't touch it, right? You cannot just go ahead and change it, because you don't know what is going to be the impact of that. Will it break, or will it introduce some new, or uncover some new bugs, right? That's raises a problem, right? So development slows down. Okay, so let's see what is the cost of this fragility, right? What happens when all these things are in the system, right? So the cost of the fragility. So inertia of legacy, right? The inertia is slowing down. Technical debt, right? The things that you need to fix or should implement goes up, right? The velocity, how you are deploying new stuff you're bringing online, or you are actually implementing, is um, is also tapering down, right? Because you have to, once you deploy, right, or if when you make something online, you have to make sure all of those stuff that you have previously um, are deployed, right, or are published, right, are all working, because it's a single application. Everything should work, otherwise it will not work at all, right? So what happens? So your feature deployment slows down, time to market is very slow. If there are, let's say you ran a ad in one of the popular concerts, or you know one of the football matches, right, and you get a sudden spike of 100 times traffic, right, and you will not be able to scale in the monolithic properly unless you throw in a lot of monies and lot of infrastructure to it, right? So that's burning money, right? Nobody does that, right? So what we should do, we should try to optimize that. So the other very specific impact is that team get burnout, the development team, right? they will be burned out and always living in a fear that if some try out something new, it might break something, right? So that's a big problem. Okay, so what is the solution? The solution is that have been tried in the industry is something called a microservice. So what is a microservice? You break the monolithic application into small deployable chunks, and you implement implement the application in small chunk and deploy them into the production, right? So what is the advantages? So if, let's say, your one part of the system is trying to grow or trying to scale up, or you have demand, right? You didn't need to add infrastructure for other part of the system. For example, you have a user management system and order system and searching system, right? For a hotel, right? You have a reservation system, you have order, and you have user management, right? So the load on the user management system will barely grow, but the load on the reservation system will grow based on the time of the day. So let's say at the 9 a.m. in the morning, the load will be the highest, but it will taper down during the lunchtime. Also, during the some holidays, public holidays, the reservation systems will get hit much higher than the user management system. The sole because that's how the internet traffic is right now, right? So if you want to do something, not all the aspects of the applications are used by the public at the same rate. It's a different rate and different time, right? So that's why the microservices pattern is very popular in large enterprises, because it scales independently. It have the agility. um, Something like deployments are relatively easier because your scope of the deployment to the production is much smaller than that of the monolithic. It is testable. You can have mix and match of different technologies, and there are plethora of other advantages. I mean, it's a huge topic. I'm just trying to go over the basic details, right? So, so one of the patterns that we should use when converting a monolith to Strangler to a microservice is a strangler fig pattern, where you don't go with a big bang implementation where you take a monolith and immediately go and convert it to a microservice or sets of microservices, but you take one part of the monolith and just convert it to um, microservice, right? And you intelligently route traffic between the two systems so that traffic for one of the patterns, right, is going to the microservice instead of the big monolith. For example, user management can be tackled fast, right? So that's all the queries for the user management will go to the microservices rather than in the monolith, right? So this is one of the popular pattern that used for migration. I mean, it's a huge topic, of course, but there's a small gist of that, right? So, but also, right, big bang patterns generally are very hard to implement because the complexity of the system is always better to use a smaller chunk of the legacy system or the monolith system, and migrate that rather than taking a big bite and not able to handle that, right? Yeah. Um, okay. So now let's come to the design this of the microservices. So there are multiple way you can break the um, monolith to what is that called? Microservice. So you can go by business boundaries or business domains, for example, users domain or reservation domain, or something like reservation domain, right? Or reports, or um, other things like that, right? or by or in healthcare it will be something like a user storage and all those things, right? But ultimately the what one of the popular method is called the domain driven design, or DDD, right? So you as an architect, right, have to find the seam and define the boundary context, so that those business domains and software domains are matched, right? So it should be such that all those domains are organized correctly, so that uh, there is very little interdependency on each other, and they all talk the same languages. It seems to be very simple, but extremely hard to get it right or implement it in one go. So it might be a continuous implementation, but ultimately what would happen is that it would reduce friction between multiple systems that are that is going to support the whole application, and uh, it will be able to help and scale the application much more easier. Okay, so last but not the least, I would try to mention Conway's law. So this domain-driven architecture or design, right, should be similar way how you talk between two department. So the way you currently execute your business and how you talk between two department, right? It should similarly, implement that pattern. That would be much more easier than going by the business domains, right? Because business domain might be different, and there might be interleaving data between two or three, or between multiple domains, right? So it's a huge exercise, which as an architect you should do, so that there are cross domain chatter is minimized, and only pass messages, or you only pass data between each domain, which is absolutely required. Okay, moving on. So this is the um, case study for the hospitality industry. Um, in hospitality, right, I was just talking, the concurrency is pretty high. It's very, very high, right? There are a lot of people who will be um, reservations, or booking a taxi, booking planes, booking property, right? Hotel stay, right? So the spikes are not, or the traffic pattern is not um, constant. So it varies by the season, it varies by time of the day, it varies by a lot of factors, right? It varies by, like, if some event happened, if there are like some social events, right? It can also vary that, right? It can create a spike for that, right? So yeah, so the major pattern that have worked in this industry is make it elastic and take care of the availability, right? So it the user is okay to wait 1 minute or 2 minutes or 15 minutes to get the confirmation on the reservation, but ultimately, right, the data needs to get to be correct. So uh, and data needs to be correct, right? So speed is required, but concurrency is the actual ball game here. So you need to handle a lot of traffic in parallel rather than yeah, instantly. Also, the data needs to be eventually consistent rather than consistent at the get-go. It is better if you can do instant consistency, but user, like, or the guest, are okay if they have to wait 5 minutes to get a confirmation email, right? So yeah, moving on. Healthcare, right? So healthcare have a different pattern. So here, eventual consistency will not work, right? So either the consistency need to be there, absolute consistency need to be there. It should be auditable, um, and details log, right? What happened and who accessed those records, was anything was leaked or not. And HIPAA is a big compliance pattern in healthcare. So there's a different way of implementing. So when you do all this, right? So you invest a lot of your efforts in making sure that your audit logs are correct, your compliance is correct, your data are immutable, nobody's able to mess with the data and all those stuff, right? So these are two different aspects of the software industry in two different domains. So as we said, right? So even though it's backend, you are writing in same type of languages, right? So based on your domain or where you are working or what you're trying to achieve, your you implement stuff a little bit different, right? If you're a startup, you go you write a monolith, it's absolutely fine. But if you are going with something called something where the auditing is much more required, right? It is it is paramount that you make it able to scale and scale, and your availability is always high, right? So, but when you go to microservice world, right? So a lot of different problems comes up. Previously you had one application, now there are many, so all the problems multiplies by number of microservices you do, right? So microservices, it solves one set of problems but does introduce its complexity. It's when you have 10, 20, 30, 40, or hundreds of microservices, right? Your complexity increases that many fold. So it becomes, so observability is not an option. You have to understand what is going on in a system, what is happening in real time, right? So you have to have distributed tracing, chaos engineering to test, like if your application is surviving the infrastructure failure or database failure or transaction failure, right? And how you are tackling that. So automated governance. Your system should be able to recover within seconds or milliseconds, right? Not in hours or 2 days, right? That will not fly here. You need to automatically route traffic to different data center based on if something bad happens to your existing data center, right? So disaster recovery need to be automated. Okay. So closing thoughts as an architect, the digital transformation from a monolith to a microservice, or from startup culture to a corporate culture, right, is not going to be an application code that you are writing. It is going to be it is absolutely a human problem, right? As an architect, right, we should be guiding the culture at what is required, what is not required, what works, what have worked, right, what doesn't work. And you should design the system based on a single assumption that system are gonna fail, and how we are gonna tackle that, right? Systems are gonna fail, there is absolutely guarantee of that. And how you're going to recover from it and how fast you're going to recover from it, that should be your goal when you are scaling an application or sets of application for a company. Thank you. I'm Saptarshi again. If you have any questions, I'm open for that.
Hello. Sir, I had a question about microservice actually.
Yeah.
In large scale systems, how do you decide when a bonded context should become a separate microservice?
So that's a very hard question to answer you unless you actually look into the what is the topic, or how the messages are, or how you are communicating, how the services are communicating between each other, right? So the bounded context need to be separate from what you have. It might or not is to be separate, but might be separate from the um, business domains, right? So users, there's, let's say there are user domain, right, and there are reservation domain. There is a possibility that your bounded context will have some part of user and some part of reservation based on how the organization is set up, right? So it is very hard to discuss that unless you have that. So so there is no one-to-one mapping between bounded context and microservices. So they can be one-to-one, one-to-many, or many-to-one, right? All depends on the scenario.
Thank you, sir. I got my answer. Are there any other questions? They can raise their hand.